Tutorial 7. The capability. In today's tutorial, we will make our first use of capabilities. Capabilities are basic to efficient logic use. This will become clearer as we advance through the tutorial. This time round, we won't load anything but simply start with a clean slate. Today's game is going to be all about babies. We're going to create a game with different baby types. One is super strong and can walk through obstacles, and the other one gets thrown back when it hits an obstacle. Using what we've learned so far, we will create two completely separate babies, each with its own logic and animation configuration. We would have to duplicate the events and the actions even when we would like both our babies to act in the same way. To save redundancy and reduce the amount of work we have to do, I will now introduce a new object type, the capability. So far, we worked with two object types, sprites and controllers. Sprites were used when a visual or a physical representation was required, and controllers when creating a game manager that works in the background. Capabilities, on the other hand, are not a completely different type and are sort of an abstract or partial sprite. Just like sprites, capabilities may contain both visual elements and logic. The difference lies in the fact that neither is really required. In other words, using a capability, I can define some logic and not specify animations or animation frames. As you can realize, this will result in an incomplete object. For this reason, capabilities cannot be placed directly inside the game room and cannot be created dynamically either. Instead, capabilities can be used by sprites to inherit logic and virtual aspects. Let's demonstrate what I mean. While our two baby types are not the same, they have some identical properties. We would like both babies to be controlled using keypad keys and to have walking animations. We will start by creating an object that contains these characteristics. Notice that instead of creating a sprite, we are now working with a capability. We will now add two animations: standing and walking. As you can see, although our animations are empty and don't contain frames, no errors were added to the list. This is because, as we said before, capabilities don't have to be a complete sprite. Now we will add the movement logic. When the player presses right, we want our baby to change its speed to 30 on the x-axis. We would also like to change the animation from standing to walking. Now let's make a copy of the event and change it to a left key press. We will change the speed to -30. It is time to create our two baby sprites. We will start with our normal baby. And enter the Properties tab for the first time. This view is made up of two sections: What am I at the top and Properties at the bottom. For the time being, let's ignore the bottom half. Pressing the Add Capability button displays a list of objects. We will select the Movable capability. Moving the Resources tab, you will see that the walking and standing animations that we added to the movable capability also appear in our normal baby. The little picture at the top left lets us know that the animations were inherited and cannot be deleted. Let's add the required frame to the standing animation. And now we will do the same with the walking animation. Lastly, we will drag an instance of our normal baby into the room. Let's test this. As you can see, we have a baby that we can set in motion by pressing either right or left. Remember, the movement logic was never given directly to the normal baby. This was implemented completely in the movable capability and inherited by our normal baby. We will now move on to making the second baby, Super Baby. To save time, we will duplicate the normal baby object and rename it Super Baby. As you can see, all the logic and visual aspects of normal baby were duplicated. Let's start by changing the animations of the Super Baby and make it look a bit different. First, we change the standing animation. And now, the walking animation. We place a Super Baby instance in room right below the normal baby. As you can see, both babies are responding to our keyboard presses. Let's improve the baby's movement appearance. Let's make a baby change the direction it is facing whenever it changes movement direction. We will use the sprite rotate and mirror action. This action takes care of rotating and mirroring sprites. This might change in future when a relative checkbox is added. But currently this action operates in absolute rotation terms. In other words, the rotation is not relative to the current rotation state, but is relative to the state before any rotation was performed. This means that if you rotate a sprite by 90 degrees twice, the second rotation will be ignored. The sprite will remain in a 90-degree rotation state. The effect of rotating an additional 90 degrees requires setting the transform action to a rotation of 180 degrees. For our purposes, we'll select none, since the transformation is not performed relatively and is completely absolute. This will bring the baby back to its normal rotation state. Now, moving over to the left key press event, we'll also add a rotate and mirror action. This time, selecting mirror. We'll run the game again. Good. In addition to changing movement direction, the babies now change the direction that they are facing. Notice that only a change in the movable capability was required, and that both normal babies and super babies were affected. This demonstrates one of the great advantages of using capability when designing games. Logic that is shared between objects only needs to be changed in a single location, and no duplication is required. We will now add the obstacle sprite of our tutorial, the cabinet sprite. Our sprite will have a single animation. That's good. Before placing it in the room, we will take advantage of a new concept. Path. So far, all of our characters' movements were done by either repositioning sprites or giving them speed. These methods are effective in most basic cases, but sometimes a more complex movement is required. This is where paths come into use. Let's go to the room designer and demonstrate the path. Pressing this button, we can start drawing our path. A path is simply a series of points in the room that define how our sprite should move. As you can see, another position is added every time the left mouse button is pressed. Drawing a mouth drawing can also be cancelled by pressing Escape. Let's start drawing the path we will use in our game. Notice that a grid appears to make it easier for us to draw exact straight lines. The grid can also be turned on manually in the toolbar to help you to accurately place sprite instances. We would like our cabinet to move back and forth. For this, we will draw a simple two-point path. We press Enter. And the path is joined. We'll name it Cabinet Path. Path may be used by all visible objects in the game. Objects using path are listed in the path branch in the Game Objects tree. Now we'll add a created event to Cabinet. and apprehend a move in path action. Self is the right target. We'll select our newly created path. Back and forth is also good as the behavior. We'll give it some speed. We'll place 2 cabinets in the room, one in front of each of the babies. Let's run it. As you can see, the cabinets are moving continuously back and forth. We can move our babies towards the cabinets, but as you can see, nothing happens when they collide. We will change all that. First, we will add a collision event between the super baby and the cabinet, destroying the cabinet when they meet. Let's make normal baby's logic a bit more tricky. We need another capability. Throwable. Throwable is going to have 2 animations: standing and thrown. We will add a collision event between the throwable and the cabinet. First, we will change the animation to thrown. Second, we will give the object speed to the left. And lastly, we will set timer 1 to be called in 300 milliseconds. What we would like to achieve here is to have the baby thrown back whenever it collides with a cabinet. The timer action's purpose is to make the baby stop when it has been thrown back far enough. For this to work, we still need the timer 1 event. In here, all we need to do is change the animation to standing and set the object's speed to 0. Moving back to the normal baby, we now add our new capability. Oh, look at that! The studio detected that we already have a standing animation in our normal baby. Our new standing animation has the same meaning as the normal baby's standing animation, so we'll select Keep Current Animation. As you can see, the new thrown animation has been added to the list. Let's run our game. The two cabinets are moving at the right. Let's move towards them with our babies. Super Baby goes right through the cabinet, destroying it. The normal baby cannot pass through the obstacle and is thrown back. We can try going through the cabinet as many times as we like, but we will always get thrown back. We'll save our game, calling it Mo Baby 1. This brings our tutorial to an end. In the next tutorial, we will upgrade our little baby's mini-game with the help of properties.